Good day to our course mates and lecturers. We are the members of Group 2 from Set 1, and our integrated project for this semester is the production of ethylene glycol from polyethylene. Ethylene glycol is a clear, odorless, and sweet-tasting liquid. Its chemical structure is shown on the right. This organic compound has many applications, for example, antifreeze, paint, plastics, and cosmetics. Ethylene glycol is biodegradable and it's toxic towards humans. It is produced from ethylene with ethylene oxide as intermediate. Next, we have the physical and chemical properties. Ethylene glycol has many other names too, such as monoethylene glycol, 1,2-ethanediol, 1,2-dihydroxyethane, and so on. Its physical state is a viscous liquid and it is colorless. Its molecular formula is HOCH2CH2OH. Its molecular weight is at 62.07 grams per mole. Then we have the boiling point and melting point. The ethylene glycol has a boiling point of 197.6 Celsius and a melting point of -13 Celsius. The pH value is 5.5 to 7.5 at 50% aqueous solution. Ethylene glycol, it is soluble in water and acetone, and it has the density of 1.11 grams per cubic centimeters. Its vapor pressure at 20 Celsius is 0.12 mmHg.
For economic issues, the figure shows the demand and supply of ethylene glycol from year 2018 to 2024. Since ethylene glycol has many usage in industry, hence its demand and supply is gradually went up from year 2018 to 2024. The design of ethylene glycol production is aimed to produce 53,600 tons of ethylene glycol annually, where the plant will operate 345 days per year, with 20 days left is used for cleaning and maintenance process for the machine in the factory. Hence, the production rate is estimated to be 6,473.43 kg per hour. Next.
Good day, I'm Ellen. Next will be the process description of our production of ethylene glycol. At the beginning of the process, we use high-density polyethylene HDPE as our raw material, which will undergo depolymerization by pyrolysis process to form oil and gas products. The polyethylene is fed to a fixed bed reactor with presence of nitrogen gas, which act as carrier gas to ensure that there is no presence of oxygen gas in the reactor. The pyrolysis occurs at 780 degrees Celsius, where higher gas yields are obtained. The products formed are oil and gas mixture of ethene and propylene. Next, the nitrogen gas is removed from the system through a stripping column by steam. Then, the mixture of gases and oil undergoes fractional distillation in a distillation column to obtain ethylene, while propylene and oil are removed from the system. Ethylene is fed to a reactor and undergo oxidation by reacting with oxygen to form ethylene oxide. After oxidation process, the effluent stream that contains ethylene oxide, unreacted ethylene, oxygen, carbon dioxide, and water are cooled and sent to an adsorption column for adsorption of ethylene oxide. Other unabsorbed gas mixtures are separated out at the upper stream of the column as waste gas. Next, the impure aqueous ethylene oxide enters a stripping column to remove the remaining gas fraction dissolved in water by steam. The pure aqueous ethylene oxide then enters a packed bed reactor to undergo hydrolysis with water under high temperature and pressure. The products formed are ethylene glycol and water. The ethylene glycol solution formed enters a phase separator to separate the unreacted ethylene oxide from the solution. Lastly, an evaporator is used to remove remaining excess water for further purification. Our product, ethylene glycol, is obtained.
Next, we have the process flow diagram of this entire project. As shown, water, plastic waste, nitrogen gas, oxygen, and steam are the input streams served for the entire process, while the nitrogen and steam, waste gas, ethylene oxide, steam, ethylene glycol, and propylene and oil are the output streams served for this process. The product, ethylene glycol, exits via stream 34 as shown.
Mass balance of feedback reactor R101. Table shows the inlet and outlet mass flow rate of each component in feedback reactor. Then we check with material balance, mass in equal to mass out, which is 17,845.52 kg per hour.
For the energy balance, first we will find the heat of reaction and then the enthalpy for the inlet and outlet, and using Q equal outlet stream enthalpy minus inlet stream enthalpy plus the heat of the reaction, we get minus, and means that the heat is released for the system and the reaction is the exothermic reaction. For the waste generation and treatment, totally we got 4 waste, and the first one is carbon dioxide from stream 25, and it will be treated by using carbon capture and sequestration CCS, and for the oxygen from stream 25, it will directly release to the atmosphere. And for ethylene oxide from stream 31, it will be treated by using ethylene oxide adsorber, and for the propylene and oil for stream 11, it will be sold to the polypropylene manufacturer.
Safety issues of raw materials and products should always be taken in consideration to ensure the safety of workplace and environment. The safety information of each material will help us undergo risk assessment where it describes the hazards of substance used in the production. Each individual that is involved in handling hazard substance should understand the properties of each substance and the way to handle them. As shown in the table, the potential hazard, handling method, and storage method of each component are listed out. Continuing with the computation part of our project, we use MATLAB program to determine the parameters like concentration, flow rate, material, and energy balance. In this part, shown is an example of calculation for material balance in packed bed reactor done by using MATLAB software. At first, we type out the coding to calculate the material balance. Based on the figure, when we run the coding, the program will prompt us to input the known inlet molar flow rate of each component. After inserting, the results for the inlet and outlet mass flow rate of each component are shown. Lastly, the data of flow rate are tabulated, and we can observe that the total mass flow rate for inlet and outlet is almost the same. Hence, the material balance in the reactor is balanced. This shows that there is no accumulation in the reactor and the system can be said to be in steady state. Next. Error handling is done to ensure that the calculation of material balance in reactor can be solved since there needs to be an inlet flow rate value to obtain an outlet flow rate. As shown in the slides, an error message will pop up saying invalid input of value when we try to input negative or 0 value in the program. It will prompt user to try again by inputting a valid value. Lastly, for numerical method, we use Newton-Raphson method to determine the concentration of ethylene oxide in reactor. The equation we use is derived from the reaction part of our project. An initial value of 0.02 is assumed. Then the Newton-Raphson coding is run with required data imputed. The concentration of ethylene oxide is obtained. The value of concentration of ethylene oxide obtained by using numerical method is the same as the value obtained from using normal MATLAB coding. Hence, we are able to conclude that Newton-Raphson method can be used to obtain the concentration of each component as it is more faster and simplified.
For the chemical reaction engineering tool, the raw material that we use is a high density polyethylene, and the reactor we use is packed bed reactor, and the process is from ethylene oxide plus water and become ethylene glycol, and the catalyst we use is the sulfuric acid. And from this formula, we get that the concentration of the ethylene oxide is 0.017393 kmol per meter cube. Well, for the volume of the reactor we get is 4,260 liters.
Next, we have the separation process. For this chapter, distillation column D201 is chosen, and the table shows the streams of the distillation column D201. Stream 9 is the input stream, while stream 10 and stream 12 are the output streams. Then, the heat duty Q is calculated, which is the amount of heat required to transfer from a hot area to a cold area over time. First, we find the sensible and latent heat, and then the sum is the heat duty, which is 649, which is 6499074.79 kilojoules per hour. Then, we use the shortcut method to look for the number of equilibrium stages. First, we use the Fensky equation to look for the minimum number of stages, which is 8.1874. Next, we use the Underwood solution to calculate the minimum reflux ratio for D201, which is 0.4527. And by assuming that the actual reflux ratio is twice the amount of minimum reflux ratio, we find out that R equals to 0.9054. And finally, we use the Gilliland correlation to look for the number of equilibrium stages, which is 15.1, or just 15 equilibrium stages. The trade efficiency is 54.58%. And then we select sieve trays or perforated plates for this distillation column because they are easier to maintain, more economical, and they are more resistant against corrosion. And the diameter of the perforations are about 0.125 to 0.25 inches. The tray spacing is 24 inches or 0.6 meters. Then we calculate the diameter of the column, which is 2.09 meters, and finally the height of the column in total is 15.25 meters.
For computer-aided design, mass and energy balance in pet-bed reactor 2 R601 are simulated using symmetry software. Table shows the outlet mass balance comparison result between simulation and manual calculation. Percentage error for mass balance is insignificant, while the percentage error for energy balance comparison between simulation result and manual calculation is 78.24%. This is because the heat capacity of each component to reference temperature used in symmetry is different from manual calculation. Next.
For the conclusion, ethylene glycol is a case of the synthetic liquid that can absorb water and is seen as a odorless liquid, and the demand is expanded at the CAGR of 4.7% from 2018 to 2024, and the plant capacity for the productions of the ethylene glycol is 6473.43 kilogram per hour. And by using MATLAB, we noticed that the material balance in the reactor was balanced, since the input and the output is the same, and we also found that the concentration of the ethylene oxide is 0.01739334, and we chose payback reactor as our reactor for the hydrolysis process is because this reactor have higher conversion per weight of the catalyst compared to other catalytic reactor, and the minimum number of equilibrium state is 15, and the trade efficiency is about 54.58%, and the diameter for the distillation column is 2.09 meters. And by using symmetry, we found that the percentage error at the R601 for the total mass flow rate is 0.017%. That's all for us. Thank you.